Quantum mechanics is a branch of physics that explores the behavior of particles on a very small scale, such as atoms, electrons, and subatomic particles. It is known for its strange and counterintuitive principles, which are very different from classical physics, the branch of physics that describes the behavior of macroscopic objects like balls, cars, and planets. Quantum mechanics also introduced wave-particle duality, where particles can exhibit wave-like behavior and vice versa. This is known as wave-particle duality. The Schrödinger wave function, also known as the wave function, is a fundamental concept in quantum mechanics. It is a mathematical equation that describes the behavior of a quantum mechanical system, such as an atom or a subatomic particle. The wave function is represented by a mathematical function, often denoted by the Greek letter psi, which depends on the position and time of the particle in question. The wave function can be used to calculate the probability of finding a particle in a particular location or state. The wave function is a central concept in the Schrödinger equation, a mathematical equation proposed by physicist Erwin Schrödinger in 1926, which describes how the wave function changes over time. The Schrödinger equation is used to calculate the time evolution of a quantum mechanical system, and it forms the basis of many other quantum mechanical equations. The Heisenberg uncertainty principle, also known as the Heisenberg principle or Heisenberg's uncertainty relation, is a fundamental principle in quantum mechanics, which states that it is impossible to simultaneously determine certain properties of a particle with arbitrary precision. This principle was formulated by physicist Werner Heisenberg in 1927. The uncertainty principle is based on the idea that certain properties of a particle, such as position and momentum, are intimately connected and cannot be measured independently of one another. The more precisely one property is known, the less precisely the other can be known. The Heisenberg uncertainty principle is represented mathematically by the equation delta x delta p greater than or equal to h/4 pi. Where delta x is the uncertainty in position, delta p is the uncertainty in momentum, and h is Planck's constant. This means that, for example, the more precisely the position of a particle is known, the less precisely its momentum can be known, and vice versa. It's important to note that the uncertainty principle is not a statement about the limitations of our measurement equipment, but it is a fundamental principle that applies to the nature of the particle itself.